Okay, now for this third part of Fourier approximations, okay, we have f of x is equal to the cube of the cosine of x, and we have for the interval, okay, we have that 0 is less than or equal to x is less than or equal to 2 pi, and we're looking at a third order approximation. So we're looking at g of x, okay, and again, g of x is going to be the least squares approximation of the continuous function f, and now, so just looking at what we have in the determination of the Fourier coefficients, so we have with f of x equal to the cube of the cosine of x. Okay, now a naught is going to be the integral as x goes from 0 to 2 pi of the cube of the cosine of x dx. And right away, okay, you're going to have for the integral between 0 and 2 pi, you're going to have as much area below as above the x-axis, and so you could look at this as additive inverses canceling each other out, and without having to do the hand integration, we can go ahead and say that a naught is equal to 0. Now for what we have as we cross over to the determination of a sub 1, so you're looking at the cube of the cosine of x times the cosine of x, which would be the fourth order of the cosine of x, and the graph of the fourth order of cosine of x is going to be above the x-axis throughout, and so we're going to have a positive value as opposed to one that is negligible. And just looking at what we have for, let's say, looking at the general integral of the fourth order of cosine of x dx, okay, so we have fourth order of cosine is going to be the square of the cosine of x, and with our double angle formulas, now we have with the square of the cosine of x, we're going to have 1/2 plus 1/2 of the cosine of 2x, and since we have the square of the cosine of x squared, we're going to square this relation, and FOILing out or squaring 1/2 of plus 1/2 of the cosine of 2x. Okay, so we come out to 1/4 plus 1/4 of the cosine of 2x plus 1/4 of the square of the cosine of 4x dx. And for the first two terms, now the antiderivative of 1/4 becomes 1/4 of x. That of 1/4 of the cosine of 2x becomes 1/8 of the sine of 2x. And now we got 1/4 of the integral of the square of the cosine of 4x, and reverting once again to the double angles. Now the square of the cosine of 4x is going to be 1/2 plus 1/2 the cosine of 8x, and the antiderivative of what I have inside the integral symbol, we have 1/2 of x plus 1/16 of the sine of 8x, and multiplying this result by the coefficient 1/4, and stringing along, okay, with the first two antiderivative terms, we have the addition now of 1/8 of x plus 1/64 of the sine of 8x followed by the constant, and combining the like variable terms with the 1/4 and 1/8 of x, we have 3/8 of x plus 1/8 of the sine of 2x plus 1/64 of the sine of 8x followed by the constant, and bringing this over to the realm of numerical integration. So taking the antiderivatives, and so we got 1 over pi times what we have for the antiderivative of the fourth order cosine of x dx as x goes from 0 to 2 pi. And what's going to happen here is that the only non-negligible term will come from 3/8 times 2 pi, which we have at 3/4 of pi, and multiplied by 1 over pi. So we're going to end up with a sub 1 equal to 3/4. And looking at what we have for a sub 2, okay, so this is going to cross over to where we have f of x equal to the cube of the cosine of x times the cosine of 2x. And for this one, we're going to have as much area above the x-axis as what we do under, so we have another additive inverses type situation. So we can go ahead and say that a sub 2 is equal to 0. And for what we have in the case of taking the cube of the cosine of x times the cosine of 3x, and okay, so for what we have in the case of this particular spread, so we have with a sub 3, so we're looking at integrating from 0 to 2 pi, and we're taking 1 over pi times the cube of the cosine of x times the cosine of 3x. And we'll go ahead and attain the antiderivative in case we don't have the area underneath the x-axis to be the same as what is above. So just taking what we have for the antiderivative of the product of the cube of the cosine of x and the cosine of 3x dx. And so if I look at factoring out cosine of x from the cube of the cosine of x, so I can just take in the rewrite for this function. So I have the square of the cosine of x, and you have times the cosine of x times the cosine of 3x. And looking at what we have now for the square of the cosine of x, I can take the double angle formula where we have 1/2 plus 1/2 of the cosine of 2x. And with the sum and difference formulas, okay, so with the cosine of x times the cosine of 3x, okay, part of it we're going to have 1/2 of the cosine of x plus 3x, which we have at 4x. And we're also going to have 1/2 of the cosine of x minus 3x, which would be cosine of negative 2x. And the reason that we're going to end up with the cosine of 2x is that we have for the cosine of x is an even function, and the cosine of a negative value and the cosine of a positive value will end up being the same. So cosine of negative 2x and cosine of 2x are going to be the same. And looking at multiplying what we have throughout, and we have with the first product, we have 1/4 of the cosine of 2x plus 1/4 of the cosine of 4x. Next product, we have 1/4 of the square of the cosine of 2x. And then we have 1/4 of the cosine of 2x times the cosine of 4x. So after our first two products, okay, we have, once again, for 1/4 of the square of the cosine of 2x, I'm going to be applying the double angle formula. So we have like 1/2 of 1/4 is going to be 1/8, and you have plus 1/2 of 1/4 of the cosine of double 2x, which will be 4x. So I have 1/8 plus 1/8 of the cosine of 4x. And we have with the last two terms, these come from the sum and difference formulas, where in this case I'm going to have 1/8 of the cosine of 2x minus 4x, which is still going to be the same as 1/8 of the cosine of positive 2x. Then I have plus 1/8 of the cosine of 2x plus 4x, which would be the in this case 1/8 of the cosine of 6x. And combining like terms together, so I got 1/8, and then in cosine of 2x I have 3/8 of the cosine of 2x. And we have with the cosine of 4x, I have that coefficient to also be at 3/8. And then we have again 1/8 of the cosine of 6x. And so just taking what we have here and applying to what we have for the antiderivative. Okay, so the antiderivative of this statement, we're going to have x over 8 plus 3/16 of the sine of 2x, followed by 3/32 of the sine of 4x plus 1/48 of the sine of 6x, followed by the constant. And relaying over to what we have in the determination of a sub 3. Okay, so got 1 over pi times the integral of the cube of the cosine of x times the cosine of 3x dx, as x goes from 0 to 2 pi. And I can just go ahead and place in the antiderivative terms. So for 1 over pi times the set as x goes from 0 to 2 pi, the only non-negligible term will stem from setting x to 2 pi and dividing by 8, where we have the result to be pi over 4, and multiplied by 1 over pi, we end up with a sub 3 at 1/4. And for what we have in the case of the next phase, okay, so we have with the b term coefficients, and this is where we are taking the function f of x and multiplying by the sine of x. And for b sub 1, okay, we're going to have, again, 1 over pi times the integral as x goes from 0 to 2 pi of the cube of the cosine of x times the sine of x dx. And for this particular product, okay, now the function is going to have equal area both above and below the x-axis. So we can go ahead and say that that integral is 0. And guess what? As we go from sine of x to the sine of 2x, we had to different graph, but still equal areas above and below the x-axis. So we can say that for b sub 2, okay, we had that result to be at 0, and setting what we have for b sub 3. So we now have the product of the cube of the cosine of x and the sine of 3x. And we have for the graph, we have just as much area underneath the x-axis as we do above. And so in this case, thinking along the lines of additive inverses, we have that b sub 3 is also at 0. So the only non-negligible coefficients we have will be, in this case, where we have a sub 1 at 3/4 and a sub 3 at 1/4. And carrying over to what we have for g of x, so at order n is equal to 3, again, a naught is negative, and we have a sub 1, which is 3/4. This will be applied to the cosine of x, and our other non-negligible coefficient was a sub 3, which you had at 1/4, and for g of x, we have that constant times the cosine of 3x. So the resulting least squares approximation that we have for g of x, this will come out to 3/4 of the cosine of x plus 1/4 of the cosine of 3x.